Number 4 is also asking us to find delta y and dy. So delta y, or our actual change in y, remember it's always going to be f of x sub 1 plus delta x minus f of x sub 1. Well, in our case, x sub 1 is equal to 4 and delta x is equal to 0.1. So plugging that in, it's going to be f of x sub 1, which is 4, plus delta x, which is 0.1, minus f of x sub 1, which is 4. So you're looking at f of 4.1 minus f of 4. And in order to figure that out, we have to figure out what is f of 4 and what is f of 4.1. So f of 4.1 is going to be, again, we're plugging it into my given function. So it's going to be whatever 3 over the square root of 4.1 is. So if I plug that into a calculator, 3 over the square root of 4.1 is going to equal 1.48159. 1.48159. And then let's find f of 4. So same thing, that's going to be 3 over the square root of 4. Well, 3 over the square root of 4 is 3 halves, which is 1.5. So then delta y is going to equal 1.48159 minus 1.5. And if we stick that in a calculator, if I subtract off my 1.5, I end up with negative 0.0184. Negative 0.0184. So now let's look at the approximate change, or dy. So in order to find dy, and dy is always going to equal f prime of x times dx, I first need to find what the derivative is. Well, what's my given function? My given function is 3 over the square root of x. Well, that's another one of those that I have to rewrite before I take the derivative. Well, how do I rewrite that? Well, remember, the square root is x to the 1/2 power. And then in order to get something out of the denominator, I've got to make that exponent negative. So this becomes 3x to the negative 1/2. So if I take the derivative here, f prime of x is going to equal, multiply 3 times the negative 1/2 is negative 3 halves, x to the, subtract 1, and you get negative 3 halves. So I get negative 3 halves x to the negative 3 halves. So my dy is going to be that negative 3 halves x to the negative 3 halves times dx. So we're going to evaluate this when x is equal to 4, because that was the given, right, when x was equal to 4. So we're going to evaluate when x is equal to 4, and I get negative 3 halves times 4 to the negative 3 halves times delta x, and delta x is the same as dx, and remember that's 0.1. So grab a calculator and figure this out. So we have negative 3 halves times 4 raised to the negative 3 halves. Hit enter, and I'm going to take this and I'm going to multiply it by 0.1. And I end up with negative 0.01875. So this is negative 0.01875. Now notice that these two numbers are pretty close together, because as long as the change in x is pretty small, and our change in x now is 0.1 units, and that's pretty small, the actual change in y and the approximate, or the differential, will be pretty close. Let's continue on in this section. We're going to do the same thing for the next problem. Right? Let's start with delta y. So delta y is going to be f of x plus delta x. So 1 plus negative 0.1 minus f of 1. Well, 1 plus negative 0.1 is f of 0.9. So I need to figure out what are all those values. So f of 0.9 is going to be 2 times 5 times 0.9 minus 1 over 0.9. Because again, we're just going to plug in 0.9 and all the x's in my given function. So calculator again. So 2 parentheses 5 times 0.9 minus 1 divided by 0.9. So what we do here is what we get here is 6.77778. I think I can make that into a fraction. Let's try. 61/9. So just to get an exact answer, we're going to say that this is equal to 61/9. All right, now we need to find f of 1. Well, f of 1 is going to equal 2 times 5 times 1 minus 1/1. And again, you can grab a calculator. We don't really need to for this one. We end up with 4 because 5 minus 1 is 4 times 8. Times 2 is 8. So we end up with 8. So then what is the actual change in y? What is delta y? Well, that's going to equal 61/9 minus 8. And in a calculator, if we figure out what 61/9 minus 8 is, so minus 8, we end up with negative 1.222. So negative 1.2222. Wonderful. What is the differential? Well, in order to figure out the differential, I first need to find the derivative. So what's the derivative here? Well, look at the given. Our given f of x here is that f of x is equal to 2 times 5x minus 1/x. I need to rewrite this before I take the derivative. The first thing I'm going to do is distribute my 2 to both. So if I distribute my 2, I get 10x minus 2/x. Now I've got to rewrite it to get that x out of the denominator. So the exponent on that x, remember if there's no exponent, it's a 1. So it would become negative 2x to the negative first. So I have 10x minus 2x to the negative first. So now let's take the derivative. What is f prime of x? Well, the derivative of 10x is 10. When it's 10 and just a variable, it's just always going to be that coefficient, because remember, the x becomes x to the 0 power, and that's just equal to 1. Here, negative 1 times negative 2 is plus 2x to 1 less, so negative 1 minus 1 is negative 2. So now my differential dy is equal to 10 plus 2x to the negative second times dx. So what I need to do now is evaluate that differential when x is equal to 1. So we say 10 plus 2 times 1 to the negative second times the dx. Remember, my dx is that given negative 0.1. And again, just grab a calculator and work the problem out. So if I work this out in a calculator, so I have 10 plus 2 times 1 to the negative second, and I get 12, and I multiply that by negative 0.1, and I get negative 1.2. So my dy is equal to negative 1.2. Now again, notice how close these two are together. Again, it's because that movement or that change that we did away from x is pretty small. So if your incremental for x is pretty small, then the differential is a great approximation to the actual change in y. All right, so let's look at this in terms of a word problem. So we say that the relationship between the soup box's quarterly profits, P of x, and the amount of money x that it spends on advertising per quarter is described by this following function. P of x is equal to the negative 1/8 x squared plus 7x plus 30, where x is between 0 and 50, where P of x and x are both measured in thousands of dollars. So use differentials to estimate the increase in the profits when advertising expenditure each quarter is increased from $24,000 to $26,000. So use differentials to figure this out. So remember, differentials is dy is equal to f prime of x times dx. So the first thing I need to do is figure out, well, what is f prime of x? What is the derivative of the given function? Well, this is my given function, right? My p of x is equal to that negative 1/8 x squared plus 7x plus 30. So what's the derivative of that function? Well, if I multiply that 2 there, I get that p prime of x is equal to negative 2/8 reduces to negative 1/4. X to 1 less, so 2 minus 1 is x to the first, plus, remember, 7x it's going to be 7 because it's going to be an x to the 0, and x to the 0 is equal to 1. So whenever it's just the x by itself, it's just going to be that coefficient. The derivative of 30 is 0 because the derivative of a constant is 0, and we don't need to write that. So the derivative here is negative 1/4 x plus 7. Great, so I have dy is equal to now that negative 1/4 x plus 7, but I need to figure out what my change in x is. So what is the change? What is the change in x? Well, the change in x is the difference from going from $24,000 in spending for advertising to $26,000 spending for advertising. Now remember, this is measured in thousands of dollars, so really we're going from 24 to 26. So our delta x, which is the same as our dx, is a movement from 26 to 24, or 2. So our dx is equal to 2. Why? Because we increased our spending by $2,000. Again, we're measured in thousands of dollars, so our dx is going to equal 2. So now I need to figure out what the x is. What am I plugging into? So what do I plug in so that I know what the differential is, how much I think my increase in profits is going to be? Let me go back up to our last problem. We are given that x is equal to 1, and we're given how much we change, right? So we always plug in when we're doing our differential that given x equal 1. So knowing that, we know that here we're going to have to evaluate this guy when x is equal to 24, because 24 is where we start at. Our increase is 2. So now plugging in so that I can evaluate my differential, I know that this would equal negative 1/4 times 24 plus 7, all of that times 2. And we can just plug this into a calculator. So on a calculator, we'd have negative 1/4 times 24 plus 7. Hit enter, and then you take that and you multiply it by 2. And so my dy is equal to 2, which means that if I increase advertisement spending by $2,000, my profit should increase by $2,000. So if I increase my advertising, my profit should increase by $2,000. That's it for section 2.6.